Hey guys, today we are solving LeetCode problem 865, smallest subtree with all the deepest nodes. So let's start with the problem. It is given that the root of the binary tree, the depth of each node is the shortest distance to the root. That is the basic definition of the depth of the tree, depth of each node, you can say. So second thing they have written is they want us to return the smallest subtree such that it contains all the deepest nodes in the original tree. Okay, basically given us the definitions of everything. So when I looked at this problem first, I noticed two things. That is the depth of they want depth. This problem asks us to calculate the depth of the tree, basically the depth of the tree. So if you haven't seen or if you haven't solved the problem to find the depth of the tree, you need to check that video from YouTube somewhere. uh, because you can't solve this problem if you don't know the if you haven't solved this problem. Okay, so then they are asking us to calculate all the then they want us to return the smallest subtree that has all the deepest nodes. So let's look at here what are the deepest nodes here. So if I label, if you see this tree, this is my level 1, this is my level 2, this is my level 3, and this one will be my level 4. So these two nodes are my deepest nodes. If there was a node here, then all this would have my deepest nodes. But for now, this one only is my these two are my deepest nodes. If let's suppose this one wasn't here, then this one would have been the deepest node. But for this example, these two are the deepest nodes. So they want me to return a subtree that has all the deepest nodes. So I could have returned this is a tree that has the deepest nodes. This should be my answer. This could have been my answer. If I return this also has this tree. Okay, this tree also has these two nodes that are the deepest nodes. So I should be able to return this. But they are asking me to return smallest subtree. That smallest word is more important. That's the intuition part. That smallest, they are asking me to return the smallest subtree. So here the smallest subtree would be this. It has only three nodes, so they want me to return this. So let's see how we can tackle this problem. So first of all, the basic intuition was that I need to find the deepest node. Okay, deepest node. So how am I going to do that is by applying DFS. So basic DFS calls that will give me the depth of depth of the subtree. So if you have known the algorithm, it will give me depth of node from here 1 1. This depth of tree from here is 2, here is 1, here is 3, here is 1 1, then here's 2, and there is 4. Okay, so that's how my depth first DFS will give. But then I realized that we have to store this, or we have to make something of a connection between the node and the depth of the tree. That is, we have to store the depth of the tree from that node and associate it with the node. Best way to do that we know is hash map. So we're going to use it. So what we're going to do is we will basically calculate the depth of the tree like this, applying DFS, and calculate depth of the tree and store it with a map that will give us everything. So now the basic part is complete here. But now how are we going to find that smallest subtree? That's the main problem. So if you look here, you will notice this is my tree. So if I look in this node, I will first check if both of the subtrees are available here. Here there is a 5 and there is a 1. So there is a 5 and there is a 1. So both of them are available. So in this case, what I'm going to check? What I'm going to check is which subtree, of these two has the deepest nodes. So I will notice this depth of this tree. So I will check for 3 and 2. So 3, obviously 3 is greater than 2. So this will, so I from here I will get that I want to search in this tree. I want to search in this subtree. So I'm going to do that. So I will call for this subtree. I will let the function to call, and then the function will call for this subtree. So this subtree, now when I reach 5, I will again check. I can either go to 6 or I can go to 2. So I will check which one has the maximum depth. Here it says 1 and here it says 2. So obviously I'm going to choose 2. So when I reach here, I again have two choices, 7 and 4. Now, one thing to notice here is both of them have same depth. So that's my basic answer. Whenever okay, so that's yeah, I wrote it down. It is easier than two. So whenever I reach a node where depth of the light child, whenever I reach a node, reach a node where depth of L child equal to right child, that will be my answer. That node I have to return. That node I have to return. So that's the base case of it. So what if we don't consider this part of the tree? Okay, so let's take this example. If I had 3 and then 1, let me write it down here. 3 1 4 5 1, something like that. Okay, so what would have been the case? So this is my root. Let me calculate the depth. We will first apply and then store it in the map. 1 2 1 3 4. That would have been the answer. So now what I'm going to look from this route, where I can go. I There is no subtree here, so I cannot go here. So I have to naturally move here. So I will call for this node. This node, when I call for this node, this will check from I can go here, I can go here, but there is 2 is greater than the root, so it will go to the 2, that is 4, this node. Then from here naturally there is 1, so it will again call for 1, and this will return the answer to the above. This will return here and this will give me the answer here. So that's the basic logic of it. Let me just show you the code of the solution. So this is the Java solution of the problem. Here you can see that this is my main, this is the first function. This is for calculating the depth of the tree. So here this is simple. This will call the left, this will call the right. It will check for the maximum depth, like in this example. Here you can see this is 1, this is 1, this is 2. So it when it reaches this point, it will check which subtree has the maximum depth. This has the maximum depth, so it will add 1 to this and return the value. So that's it, the maximum. It will calculate the maximum, and then it will put this into a map. This map with the root and the maximum depth of that subtree, and it will also return the maximum depth. So then I write the find function. It will return tree node. It will return the node. So what it does, it first check if both of the left child and the right child of the tree are null. So let's say if my tree has only one node, then that will be my smallest subtree that has the deepest nodes. So that's the first case. Then it will check if my tree has a left child or not. If my tree doesn't have a left child, it will directly call to the right subtree. It will directly call to the right subtree. As you can see here, okay, one second. As you can see here, there is no left child, so it will directly call for the right child. Similar to that, if the tree doesn't have a right child, then it will directly call for the left child. That part is clear. Then if if my code runs till this point, then I'm pretty sure that that node has both left child and right child. So what I'm going to do is get the values of the depth of that both of the child. So here I'm getting that from the map. I have stored it in the map, right? So I'm getting that values from that map. So when I get those values, left depth and right depth, then I will check for if left depth is equal to right depth. That we case here. That's the case here. Whenever I reach a node where the depth of left child is equal to right child, my answer will be that node. So I'm returning that node here. Now then there is this, if the left child has depth greater than the right child, then I will return the left child, and That's the else part, that if the right child has depth greater than the left child, then I will return the right child. So that's the basic function of it. I hope you have understood the problem. I tried to explain it in my words. Yeah, thank you for watching. If you have any doubts, please don't forget to mention in comments. Thank you. Have a good day.